the switch in the circuit of this figure had been in position 1 for a long time until it was moved to position 2 at time t equals 0. Determine v of t for t greater than or equal to 0, given that, and then we have the information for all of the different stuff in our circuit. So we're looking for a function v of t for t greater than or equal to 0. So we're not looking for a number, we're looking for a function. Okay, so it's an RC circuit, and so we're looking for voltage, and we know that, and you should just kind of get in the habit of writing this, Vc of t equals Vc at infinity plus Vc at 0 minus Vc at infinity e to the minus 1 over tau times t. Okay, so our job is to find Vc at infinity, Vc at 0, and tau. Because if we find all of those things, then we are good to go. Okay, so the first thing we'll look at is Vc of 0. Now, we'll notice that this is a capacitor, so that and a capacitor cannot change voltages instantaneously. So this means that Vc at time 0 has to equal Vc at time 0 minus. That if we look at what the voltage was across the capacitor at 0 minus, that has to be what the voltage is at time 0. And this is how you do it. So you look at what it was before, and then that'll tell you what Vc of 0 is. So what we have to do is draw our circuit the way it was before 0, and then figure out what we've got from there. Okay, so it was in position 1. Okay, so that means that this part right here, that's not coming into play at all. And because I don't like current sources, I'm immediately going to do a source transformation on these two right here. So a current source and a resistor in parallel equal a voltage source and a resistor in series. And our voltage will equal IR, as voltages are wont to do, and that's 6 milliamps times 4 kilo ohms. The milli and the kilo cancel each other out, and that gets us 12 volts. The resistor doesn't change, and that's 4 kilo ohms. The switch was in position 1, so it's right there, that was our switch. We have a capacitor. Now, it had been for a long time. So for a long time, a capacitor under DC conditions acts like an open circuit. So that's how I'm going to draw it, is as an open circuit. And this voltage source is 18. Did someone not tell me that 6 times 4 is 24 and not 12? Yeah, y'all need to tell me these things. Because I will forget to look over my notes, and then I will do things like multiply 6 times 4 and get 12. Okay, 18 volts, and then we have another resistor down here, that's R2, which also is 4 kilo ohms. Okay, so this is at 0 minus. This is at time t equals 0 minus. And I want to figure out, and also it's important to know which side is labeled plus and which side is labeled minus. I want to know what the voltage is at 0 minus. Well, there's no current flowing, so there's nothing going on here. And if I make this ground, That doesn't mean there's not voltage, but there's no current. So if this is ground, the bottom is 0, then up above this voltage source is plus 24, and up above this voltage source is plus 18. So the plus side of our capacitor is 24, the minus side is 18, and so VC of 0, you always do the plus minus the minus, is 24 minus 18, which is 6 volts. So that's a VC of 0. Okay, so now let's take a look at VC at infinity. So now we're going to say that we have closed the switch right here, right? Yeah, has moved to position 2 at t equals 0. And so now our circuit looks like this. Now we're at infinity, so it's been a long time again. So I'm going to go ahead and write my capacitor like an open circuit again. So if I make this ground, up above this 18 volt voltage source, this would be 18 volts. And over on this side would be 0 volts. And then to find the voltage, you take the plus minus the minus. So that'd be 0 minus 18 equals minus 18 volts. Okay, so I now have VC of 0 was 6 volts, and I have VC at infinity is minus 18 volts. Next thing I need to do is get tau. So to get tau, I look at my circuit during the time period that I'm interested in, which is after the switch has been thrown. So it looks like this. And I want to get the equivalent resistance of this circuit. Now, ordinarily, I would say, well, you short out the voltage source and you go from there. But this one, obviously, the resistance is the resistor. There's only one of them, so we don't have to do any much work on this. So this is R2, and R2 is 4 kiloohms. So tau is RC, which is 4 times 10 to the third, and the capacitance was 200 microfarads, so that's 200 times 10 to the minus 6, and that ends up being 0.8, and the units of a time constant are seconds, because it's a time. And then I like finding 1 over tau, so 1 over 0.8, and 1 over 0.8 is 1.25, and again it just makes for a prettier final answer. So VC of t equals VC at infinity plus VC at 0 minus VC at infinity, e to the minus 1 over tau times t. So VC at infinity was negative 18, plus VC at 0 was 6, minus negative 18. E to the minus 1 over tau is 1.25 t, or negative 18 plus 24 e to the minus 1.25 t, and our units are volts. Okay, I'll come back to this page in just a second.